Good afternoon. Thanks for the chance to present today on the work that SeaEnergy and Robert Gordon University are doing. I hate to start with the statement that you're the only ones who don't know that free drinks are being served over in the main hall. Thus the low number of people. Today I want to talk about dynamic modeling for offshore wind operations. This is a collaborative project between Robert Gordon University and SeaEnergy with support from the Technology Strategy Board. And that is via the KTP, the Knowledge Transfer Partnership. And I'd like to take the chance to recognize Peter and Thrasos both in the audience here. So today I just want to talk about a few things related to dynamic modeling and work my way up to why we came to this approach for offshore operations. So I'll talk about some industry trends on where we're going, talk about how it's becoming larger wind turbines in, further from shore and in deeper water. I have a slide with one wind turbine to try to make the idea of offshore wind simpler, to understand why it is that we're trying to proceed down this project path. We'll talk about operations and maintenance in general and what's been done so far with modeling, and then look at our rationale, conceptual approach, and various data streams that we're going to need in order to accomplish this. And it's somewhat presumptuous, I guess, to say the solution, but this is the solution that we see that will be inevitable in the end in the offshore wind industry. So we all know, in this room at least, where we're headed. We're moving offshore in a big way. The trajectory of that line is undeniable. But why are we doing it? What is different on the offshore environment compared to onshore? The reason we're going there is the capacity factor. We can extract more energy more consistently than we could onshore. But what happens simultaneously is that the availability becomes more difficult to maintain offshore because availability sits squarely on the shoulders of your operations and maintenance strategy. And under your operations and maintenance strategy, you have asset integrity management programs that you're trying to implement, whether it's PAS 55 or ISO 55000. And if you're an operator and you're not doing that, please come talk to me afterwards. But you have a number of issues under availability, such as access solutions for various vessels. You have, as I said before, challenges implementing your asset integrity program. So thus, it's getting us towards the need for dynamic modeling. This is just more evidence behind why we think dynamic modeling is important. We have bigger wind turbines, so that means when something goes wrong, it becomes even more valuable, and it's even more important to fix it as soon as possible. We're moving into deeper water. I think we all know the graph on the bottom left. We're working in deeper water, further from shore. And then, as a former geographer, I always like to put up a map because it tells a story. As I said, I used to be a diver for the Navy, and I also worked in the Foreign Service. So that map, to me, looks like an extremely complex, multinational marine environment that's going to take a lot of dedicated tools to improve our performance in that space. So here's my story in one wind turbine. Now, we can all argue, I think, and we probably would if we had time, of the various numbers that we've laid out here. But the idea being, we have a particular wind turbine that we're putting out at sea. We have a particular wind speed that we expect. We have a tariff in this country or in other countries that we're likely to receive. But we also have a cost for generating that energy. And as a result, our margin is quite small in the end. Now, we can debate this. It changes as we add different scale turbines and different wind speeds. But nevertheless, there's a margin. And as an industry, over the years, the lines go down, and our pressure to reduce the cost of energy goes even higher. So we start to realize that small improvements need to be made again and again and again in order to widen that margin or increase that margin. I was thinking on the way here today that it's a bit like in the Olympics with Chris Hoy. I think their strategy was marginal gains, right? Every single thing they could think of that would reduce a small bit of time, they implemented. And when you add it all up, you get large improvements. And this is a very similar thing. So the issue is that we're talking about today is availability with dynamic modeling. How do we improve availability? And if you look at just a 1% increase in availability for one wind turbine based on these ratings, you get a substantial amount of money that you didn't have before. If we take that across the whole industry, across the North Sea, we're talking about substantial amounts of money. Of course, this is all predicated on the idea of levelized cost of energy and this formula down at the bottom, which we're all familiar with, I'm sure. But we need to bring that number down one way or another. And another graph that we all know on the top here is there's a relationship between availability and the cost of that availability. So as you approach 100% availability for the wind turbine, your cost goes out the roof. Right? It's not possible in the end, but you want to get as close as possible. So pushing the optimal curve down to the right is what we're trying to do. And we feel like dynamic modeling, which improves the ability of the O&M team to maintain availability, is key. Oh, sorry, back here. At the bottom, there are O&M models in existence. We know the ECN and others work on O&M models. Some of them are related to weather specifically. Some are particular for offshore. Some are in the commercial space. We have colleagues out there that do this as a consultancy basis. We have some that are long time horizon, which to me means strategic. You're looking at a static environment where you're trying to improve your ability to set up optimize your vessel fleet perhaps, or pick the right port to be the cheapest at the end. But there are very few short time horizon dynamic models, if any, in the space that we're thinking about. So the rationale for us at SeaEnergy and RGU to go down this path is that as an operations manager of a wind farm, I don't know if there are any in here, but you must pull your hair out day after day, taking account of all the various variables, planned maintenance, unplanned, repairs, spares, the list goes on. What competence your technicians have that day, emergency response responsibilities that you have, SCADA data coming in, marine traffic depending on where you are, the production value that you're losing by not getting out there, mean time to failure, and it goes on and on and on. All these variables that you have to incorporate, process, and then decide what to do. So the question is, in your wind farm, you're at wind turbine number 24, you've just fixed it. Where are you going next? And why are you going there? Are you going because it's the best value, or are you going because that's the planned repair for the day? Right, so this is the idea that we're thinking through. Our conceptual approach at SeaEnergy is essentially in three large areas. On the left is the static area, as I said before, where you have a number of variables that never change. You have the port location, the depth of the water, potentially the average wind speed. All these variables are what they are, and they're going to be that through the years. There's a period of time before a wind farm gets built where those need to be optimized, obviously, and there's a lot of work going on in that space. In the center is the hybrid model that focuses on months or month, where you think about the issues associated with, do you have the right technicians lining up on the quayside, getting ready to go out to sea? Do they have the skills required to fix the things that are happening out on the wind farm? Do you have the right spares coming through? Do you have a just-in-time supply chain system that delivers things as you need them, or are they in the warehouse? Optimizing that process is key as well. But it doesn't yet get us to the dynamic period, which is the last, which is focused on days or hours or minutes, where when you're on the vessel, and you have a limited amount of time and weather is coming, where do you go next? What's the best value approach? So this is what we're thinking through. And I'm not standing here saying it's easy. You know, we have a dynamic model. If we think about all the various data that comes in, it is substantial. I mean, I feel for the Sparta team dealing with all the data. We'll have the same thing. We have issues associated with technicians, their competency frameworks, the job cards that they have to have a permit to work system to allow someone with the right competence to work on the right job. They have technician tracking programs right now where keep track of where people are for health and safety reasons. So that could be one data stream. Another is associated with your operator targets. They have targets that they want to hit for the year, whether that be availability, the cost of operations that they want to keep down. They want to keep track of the value of lost production, obviously. These are all potential data streams that could come in. Another being, with your vessels, you have all sorts of issues associated with the vessel capabilities. A vessel can only do certain things based on the sea state or the weather. You have health and safety limits potentially with your vessel, and I'm looking forward to G9's presentation on that. You have acceptability levels like motion sickness index and other variables that need to be kept track of, as you're out doing work. Then, of course, you have all the environmental data, and we have environmental monitoring companies out there in large numbers who are doing this. So all of these data streams, these and more, have to come in and then be synthesized and spit out an answer on where do you go next. And you can see that as your options are all out on the table, they begin to be limited by the wave height, perhaps, the technician you have on board. If you have the wrong technician, you can't do a certain job. Right? So you begin to filter down to what's possible. So that's why we feel like dynamic modeling is an inevitability, because there are too many factors out there for the human brain to process. So this expert system or tool filters it down to where it's a manageable set of decisions to be made. So this is what we feel like the solution is in the end, is some way to optimize the access to your assets, because your turbines are running more often, your availability goes up. I say technicians are cheaper. That's not the right word. You're getting more value out of the technicians. If they're on shift for 12 hours, you want them working as many hours as possible on productive things, because you have an asset integrity program that you want to get through for the year. And if you only get 2 or 3 good hours out of them a day, that's not good value. And of course, you want vessels fully utilized. Just a slight plug for the SeaEnergy SOV here. You want to make sure that you're using that vessel in Dogger Bank in round 3, 24 hours a day, 7 days a week, to get the most value out of it. And it comes back to this. What's the rationale? As I said at the beginning, you need to fully exploit the capacity factor. That's why you're there. You need to make sure that you use it. Your availability is improved. Right? Your decision-making with this dynamic tool allows you to ensure that the value of production is maximized. And your asset integrity management program, or your program itself, is better implemented. There are a lot of plans out there that never actually get implemented, and this could help to improve that. And this margin that we talked about, this is the key, how to continually widen that step by step by step every day. So in conclusion, I think I hope it's clear that the rationale for this is, as the wind turbine size increases and we move further from shore, each and every O&M decision becomes more valuable or more costly if it's not taken at the right time. And with low margins, a dynamic tool like this that ensures that you maximize the availability could be the difference between a viable wind farm and a non-viable wind farm. So we feel that the value of dynamic modeling is you have to do it rigorously every day and consistently apply it, because if you design it well, it will learn from itself and become better and better and better, and therefore your application of your asset integrity program will be even more efficient. That's it. Thank you very much.